Are you learning engineering? Might sound like kind of a stupid question, right? You might say, of course, my major is electrical engineering, or my major is computer engineering. Of course, I am learning engineering. What else would I be doing? But part of my student experience, and as a teacher now watching students that I work with, oftentimes what I find is sometimes they're not actually learning engineering. What do I mean by that? Well, consider this. This is a Ford F-150 truck. I lived in Michigan for a little while. As you get close to Detroit, this is a big part of Detroit. But if I were to ask you, why does this truck exist? There's actually two valid, legitimate answers to that question. One answer to that question is this truck exists because a team of engineers working together used tools of theory, math, modeling, computer simulation, testing, and above all, problem solving. Probably took a number of years, and as they did that, they developed the design and plans for this Ford F-150 truck. Another way you could answer that question is this truck exists because a team of assembly line workers did their assigned job at each point along the assembly line to put the parts together according to that design until at the end there was a truck, right? Two different answers to the same question. And what it also gets at is two very valid professions. One is engineering and one is the assembly line workers. But here's my concern is sometimes I find that students bring an assembly line mentality to education. What do I mean by that? Oftentimes a student will approach a class with a mentality that says, what I need to do is learn how to do a bunch of tasks here. My teacher's job is going to be to teach me how to do those tasks. I'll learn how to do those tasks really well. You'll give me an exam and I'll reproduce those tasks for you and you'll say, way to go. And hopefully I'll get an A. And that's actually a lot of how I approached my education when I was an undergrad, when I was a midshipman. What's the problem with that? Well, the problem is that's actually not engineering, because if you're not learning problem solving, you're not learning engineering, okay? Here's kind of a few thoughts on that, a few tips of how to make sure you're learning engineering and how to become a problem solver and not just a assembly line worker in terms of I just reproduce this task over and over, or not just a calculator, somebody who just does calculations. So first tip is this, learn by examples, don't just learn examples. Here's what I mean. I find that a lot of students, what they'll do is they'll have a homework assignment and they'll hit a problem that they're not sure how to solve it. So they go on sort of a treasure hunt in the book and they're looking for an example that looks exactly like that problem. And if they can find it, then they say, great, I'll just basically take whatever they did in that example, apply it here, and I'll be done. The problem with that is all you've done is you've learned that example. And some students then approach a class by trying to build up sort of a repertoire, a recipe book of all these different examples. And so then when they get an exam or an assignment, they can say, which one of these am I supposed to use? Pull out this recipe card, slap it on it, and make it work. What you really want to do is learn by examples. You want to look at, say, an example like this and say, not just, okay, great, how do you get the Fourier transform of this signal? But how does that help me then find the Fourier transform of other signals? How do I learn how to take these concepts so I can extend them and apply them in different areas? So learn by examples, don't just learn examples. Somewhat related was this idea is don't approach your class like an SAT prep course. Think about an SAT prep course. There is one goal in an SAT prep course, and that is to get you a higher SAT score. That's it. Nobody in there necessarily cares about the material, cares about what it's related to, what it's useful for. The goal is just learn how to do these problems so you can get a better score on that test, right? That's not what an undergraduate course is. An undergraduate course is about learning some material, but it's so we can apply it in new ways, so we can apply it in solving problems, okay? So don't approach your class as if it's an SAT prep course. Part of that then is ask why and what if questions and not just how. So an assembly line mentality towards education says, I just need to know how to solve this problem. Tell me how to solve this problem. The problem-solving engineering approach to education says, I do want to know how to solve that problem, but I want to know why that works. Why do those concepts work? What if we changed it? What if we tried this instead of this? What would happen then? Why and what if leads to innovation. Why and what if leads to applying those concepts in new ways in other contexts. How, again, just results in my recipe book of problems that I know how to solve. Here's one, a little hard to do at the time when you're a midshipman, but actually reading the textbook, and especially the intro sections when it's trying to explain to you why and what are we doing and why are we doing this and how does it connect to other things we've done before. And I found that was something I didn't really do until grad school, was actually read the textbook. But it's amazing when you do that they actually write some stuff in there that's super helpful. Now, some of you may be thinking, this is all great, but I actually don't plan to pursue engineering for a career. One of the unique things about teaching at the Naval Academy is, most of you will not graduate and immediately go into engineering, will you? And many might say, I had to choose a major. I chose one, thought it was kind of interesting, but I'm never going into this later. So I'd have two ways to answer that. One would be this, is you never know. When I graduated in 97, I did not plan at that point to go back later to a PhD and end up teaching in the field. So you never know. But the other answer is this, is problem solving, and that's again what engineering is, goes beyond just engineering. Problem solving is applicable in the fleet, right? Problem solving is applicable everywhere. And if you approach your education as becoming a problem solver, an engineer that learns how to solve problems, you can solve problems anywhere. You can solve problems in any context, okay? Otherwise, that recipe book of problems you know how to solve, and those are the only ones I know how to solve as an assembly line worker, it's kind of useless once you graduate and you're not in that context, right? If nobody asks you to do a Fourier transform again, I wonder why I learned that. But if your engineering education makes you into a problem solver, you can use that anywhere, and that's very, very applicable. So just an encouragement as you approach these classes. It's a lot of work. It's easy to get drawn into a mentality of just got to get through this. But I encourage you is don't just be an assembly line worker when it comes to education, be a problem solver.